Recording. Now we're going into chapter 3. So this is pretty much just going, the biggest point of all this is X causes Y. Your independent and your dependent variables. I wouldn't be surprised if there was a question about the goals of political research and, defining and measuring concepts, designing the answer of the what questions, example, what is a valid measurement of political tolerance? And the purpose is to text the explanation for phenomena designed to answer the why questions. Why are some people more politically tolerant than others? It's going to be multiple choice, so just kind of remember what questions and whys. So the theories are what help us identify the elements of causal relationships, which that's all we really care about is the causal relationships. And so for that, we have the dependent variable, which is what is affected in the causal explanation, and the independent variable is what does the affecting. It is the cause. So the dependent variable is the Y, independent variable is the X, and so like I said, X causes Y.
I have on my notes that the independent variable is Y. Twice I have it. Okay, never mind. I see if it's dependent. So the dependent is the Y.
Yes.
Okay. Never mind.
So then this thing about how to frame hypothesis and constructing your explanations, I'm not really sure how much of this he's going to care about, explanations must be plausible, and they need to be falsifiable. They need to be able to test that it is correct or incorrect. Then the framing of the hypothesis, which is, it's a testable statement that proposes a relationship between the independent variable and the dependent variable. So the independent variable is the cause and the dependent variable is the effect. And then a little bit of explaining how that is comparing the values of the dependent variable for subjects having different values on the independent variable. So basically you're looking at the values on the dependent variable, and then you see how when the independent variable changes, how that changes the dependent value. Any questions on that? All right. So then we go into the whole models things and how it's a simplified abstract representation of a larger, more complicated subject. Like he said, all models are wrong, some models are useful. But so we simplify by omitting unnecessary details to answer each research question. And so that's how we get down to just 2 variables. And we all know there is a crap ton of variables in the world that can adjust and affect all of everything going on. And then the one other important thing to remember is that you can have multiple independent variables, but you can only have one dependent variable. And then also you have the causal mechanisms, which are the links that act as a go-between. This whole thing about causal mechanisms, I mean, know that they exist, know that they're a go-between between the independent and the dependent variable, but I wouldn't go super in-depth into them. So then we get into the hypothesis. And so I think that the basic, like what you want to make sure you understand is that a hypothesis is a testable statement about the empirical relationship between cause and effect, or between X and Y, or between the independent variable. And then you have your research hypothesis, which, I mean, it's the same thing. But again, I would not be surprised if there's a question that it says a hypothesis needs to be, and the answer is falsifiable or falsifiable. So I did put the template here for the hypothesis, which is, you all can read that. I don't think we're going to be tested on that, but it's good to, understand that, and then understand that the existence of the null hypothesis. The hypothesis states that there is a relationship between X and Y. The null hypothesis says there is not. That's all it basically is. And so when we test it and we find that there is a relationship, we don't accept our hypothesis, we reject the null hypothesis, and then we do more research and try to fine-tune our hypothesis with our findings. Any questions on the hypothesis, research hypothesis, null hypothesis? Okay. Common mistakes during hypothesis writing. I don't think we're going to have any questions on this either, but I put everything down there with examples of what these are. So no relationship, no comparison, the tendency of the relationship not stated, vagueness, or several plausible explanations. Are there any questions on those common mistakes? Like I said, I don't think it's super important. I don't think it's going to be on there. And honestly, half the time you can do all of the above because they almost always sound exactly the same. All right, going into cross tabulations. We all know what those crosstabs are, those graphs we see. They're used when variables are categorical. I really don't like that he used this term categorical here. I mean, pretty much he's talking about, for the most part, nominals. Nominals. Oh wait, no. Or sorry, no, not, these aren't talking about it, yeah. I don't know where this categorical came from. I tried looking it up this morning, like that's what it says in the slides, and I couldn't really find it mentioned anywhere else. Did anyone have a good idea about what that was?
Yeah, I did, Gavin, or at least I have my interpretation of it. So from the reading the chapter and going back to the notes, categorical variables are variables that are just not numbers. So it's like you said, it's nominal, and also in some cases ordinal variables.
Okay.
Yeah, it was just another way to say, categorical variables are variables that are not interval level variables. So yeah, not numbers.
Okay, thank you for clearing that.
Sure thing.
Yeah, so, okay. Yeah, and then I just got thrown off by this other part, but yeah. So crosstabs, Usually they're going to have the percentages on there. Do we really have any questions about making crosstabs? Okay.
Nope.
And the other thing with it is, just this, it's like the line underneath rules where it says set up a crosstab so that categories of the independent variable define the columns of the table, and the values of the dependent variable define the rows. So your categories or your values are going to be up at the top, and it's all your numbers are going to go all the way down that way. And then on the side, labeling the rows is going to be your dependent variables. Does that make sense? I think that's probably the biggest thing we would get tested on about crosstabs.
Actually, does anyone not like have a picture of like how the crosstabs were made? I know Manchaka, like he made an example in class, but I didn't really get it.
See if I had a crosstab. Okay, let me try this. Okay, can everyone see this example chart?
Yeah.
Okay, so now obviously this is a means comparison, but so your independent variables are these ones on the top. You have your education and you have your age. And so your values for, let's just look at age. You have the values of low and you have the values of high, young and old people. So everyone that is represented in this row, in this column, is all these are young people. All these are old people. And here you have your dependent variable. And so everyone going this way, they all favor legalization. Everyone in this row. Everyone in this row opposes legalization. So your dependent variables label the rows, your independent variables label the columns. All good there? All right, and then we're on to mean comparisons, which that's where shows the mean of dependent variables for cases that have different values on the independent variable. It's going to be used when independent variables are measured at nominal level. Dependent variable is interval level. So I feel like there's more times that you would use it than just that situation, but so then we get into the graphing relationships, and this is where you can have the direct relationships, inverse, linear relationship, curvilinear. And then, so this is basically just your like normal algebraic questions, like in graphing. So you get your little thing and then it graphs it out. And so obviously a direct relationship is it runs in a positive direction. An increase in the independent variable is associated with an increase in the dependent variable. And so then the opposite of an inverse relationship is where an increase in the values of the independent variable is associated with a decrease in the dependent variable. So does everyone understand that with direct and inverse relationships? All right. Then moving on to linear. So this is where so you can have, so direct and inverse, those are like basically talking about the slopes of the line, whether it's positive or whether it's negative. And so then your linear and curvilinear are talking about what the line looks like. So a linear it's just always going to be going in one direction the same, whereas a curvilinear, it is something like a parabola, or it's curved and, it gets, goes up, the slope increases. So the first two are just talking about the direction, whether it's going up or down, and then the other one is talking about what the line looks like. Does that make sense? And already we are done with chapter 3. Are there any questions about this information in chapter 3 before we go on to chapter 4?
Not with me.
All righty then. I'm going to go ahead and stop the recording and end this meeting here. And then everyone just join back in. And as soon as I have the recording downloaded, we will start on chapter 4.